This question basically make use of exponential function. That means it is testing you on exponential equation or function. And at the end of it, there's a little bit of graph knowledge. So it is from the power function exponential graph. Okay, so I will start off by explaining to you the equation first. So some students will find this question very confusing if you don't bother to read what is the formula trying to tell you. Okay, so there is a formula here. So you got to know what are the component of the equation. So n represent the number of bacteria. So basically the idea is, right, they introduce bacteria into a culture. So after the introduction, the bacteria will be expected to grow. So that's why they are using this formula to calculate the number of bacteria after T hours. So after T hours, so this T is the time in hours. And this is the amount of bacteria introduced. That means this is the amount they introduce in, and then from there, the bacteria will keep growing. So essentially, M is like a constant. That means it's a fixed amount, don't know how much they introduce inside. Okay, then after that, the question part A, they are saying that after 1 hour, the bacteria increased to 2,000. And we are supposed to find the value of M. That means we can trace back how much is being introduced. So when we say T is 1 hour, so take note of the unit, image the unit. That means T is equal to 1, and the number of bacteria grow to 2,000. That means N is equal to 2,000. So in order to find the value of M, you will introduce these two into the formula. So you introduce it into the formula. So it's not that difficult, because if you introduce into the formula, you realize that this part will become a nice number. It's actually 2 to the power of 3, which is 8. So which means 8M is equal to 2,000, and M is equal to 250. So that is the value of M. So the significance will be they introduce 250 bacteria inside, and then after 1 hour, it grows to 2,000. That maybe part B is a little bit more difficult. Okay, so part B can be a little bit more difficult. So now with the answer in part A, and like I mentioned, this is supposed to be a constant. I'm going to put in the value of M inside the formula. So my formula right now is more completed. So it's 250 multiplied by 2 to the power of 3t. Okay, so now my formula is a bit more complete. And I would like you to know that we are interested to find the number of bacteria. That means I'm interested to find N, but I'm actually not given any value of T. So instead of giving value of T, I know this. So where does the 8 power T come from? So if you look carefully from the more completed formula, this part is 2 to the power of 3. So that means I can actually process it this way. So if I process it this way, then I will have gotten 8 to the power of T. And now I can change out this whole thing into K. That means this will be the K that is provided. So N is equal to 250 K. Okay. So the next part, we are supposed to find the increase in the number of bacteria. So take note, you are supposed to find the number of increase in the bacteria after 2 hours as the percentage of the number of bacteria originally introduced. So I'm going to make it into a percentage. So the number of bacteria that was originally introduced will be 250. So after 2 hours, what is the increase in the bacteria? So I'm going to find out when it is actually 2 hours, how many bacteria are present. So I put it into my formula. 2 hours. So when I put it into the formula, you just have to punch calculator. So in 2 hours, the bacteria has grown to 16,000. That means, right, you think about it, initially it was 250, then it grew to 16,000. So I'm quite sure you can find what is the increase in the number. So the increase in the bacteria within that 2 hours will be 16,000 minus 250. 16,000 minus 250. So it actually increased by this quantity within the 2 hours. Then I will convert it to percentage increase. So the percentage increase is, so when you do percentage increase, you use, in this case, the base will be the original bacteria, which is the 250. So you will get 6,300%. Okay. So basically, you just need to get the right footing in this question. You make sure you understood the different component in the equation. So what is the equation trying to measure for you, and what is it dependent? So in this case, we are calculating the number of bacteria that's dependent on time. Okay, so now we need to find out which is the graph that represents this. So like I mentioned at the start of the question, it is an exponential equation. It is an exponential function. So it's something like this. Okay, so I'm going to recap for you the basic one first. I'm going to recap for you the basic exponential that you know. So the basic one that you know should be these two exponential. Okay, so I draw for you first. So when the x is positive, the power is positive x, it's actually upward sloping. Okay, when when the power is negative, it will be downward sloping. So that's how a generic exponential graph looks like. You should find this in the summary of your power function. Okay, so if you don't find it in the power function, okay, you let me know. I point it out to you. So basically, for these two graphs to happen, the assumption will be A must be greater than 1. That means the exponential base must be more than 1. So it can be 2, it can be 3. Okay, so if you observe, that means this one is like the A is more than 1. And should it be a positive power or negative power? So if you look, this one is a positive power because time is positive. So we will be expecting the graph that looks like this part. So if you check it out, right, it should look like number 3. Except that the negative part is missing. You realize the negative part is missing. So why is the negative part missing? Because we are measuring, we are drawing against the time. Time has no negative quantity. So that's why the negative side doesn't happen. Okay, so that's why the answer is diagram 3. And the basic come from your idea of exponential function in your power function. So this whole question basically tests you on exponential equation and function and the drawing of the graph.